Hello, this is Ahmad Mirabi. In this video, I want to teach a bit of physics. Let's start. Work in kinetic energy. The net work done on an object is equal to the change in kinetic energy. This is a theory. It is easy to prove it in straight line. For example, when the motion is uniform, or we have a uniform acceleration along a straight line, it is very easy to prove it. I have no intention to prove it though. So the total work or work net is equal to kinetic energy final minus kinetic energy initial, which means the total work is equal to change in kinetic energy. It doesn't matter whether the work is done by you, gravity, friction, or any other force. The net work or total work is important. If you calculate the net or total work, it always equals the change in kinetic energy. By the net work, we mean algebraic sum of all works, like the one we did in the previous examples. Works done by gravity, normal force, air resistance, applied force, all of them. Algebraic sum of all of them, because some are positive, some are negative. We add them all together, and then net work or total work will be calculated. Okay, example. A 1 kilogram object speeds up from 2 meters per second to 6 meters per second. Find the net work done on this object. So the formula says the net work done is equal to change in kinetic energy. Okay, the change in kinetic energy is half of m v squared minus v squared. So the mass is 1, the final velocity is 6, and the initial velocity is, or final speed and initial speed is 6 and 2, and therefore 36 minus 4, 32, 32 divided by 2, 16. 16 joule is the amount of work, net work done on this object. We don't care about what the forces are, or what are the forces, which angle they are. We know that the total work done on this object in this movement will be 16 joule, based on this theory, based on this theorem. In the previous problem, if all data are the same and the object is at rest at the beginning, so when it says at the rest at the beginning, which means initial velocity is 0, initial speed is 0, find its final speed. So in the previous problem, we found the work of F to be 80. We found the work of normal force and work due to gravity to be 0, because displacement in that problem, displacement was 2 meters to the right. This was the direction of displacement. So normal force is this. Gravitational force is this. They are perpendicular to the direction of displacement, therefore these works were found to be 0, and we found the work of friction to be negative 14 joule. Therefore we add them all together as we did in the previous example, and we added them all. We found the net work, or the work of resultant force, to be positive 66 joule. Now, the theorem of Work-Kinetic Energy Theorem says the net work is equal to change in kinetic energy. The net work is found in the previous problem. Now we want to find the final speed. Why I didn't subtract from initial speed and initial kinetic energy? Because the initial kinetic energy is 0. Okay, what is the mass? 10. So it will be 5 times Vf squared. So 66 over 5 will be Vf squared. If we multiply both sides by 2, I'll get 132 divided by 10 is 13.2, and therefore the final speed will be found to be radical 13.2.